Okay, so let's dive right into one of the biggest challenges facing AI today. And to really get it, let me just paint a quick picture for you.
I want you to imagine a super busy airport. You've got everything from these little domestic flights to massive international jumbo jets, all trying to land, all trying to take off. It's organized chaos, right?
Now, what's so fascinating is that this is exactly the problem that large-scale AI systems are facing. In this case, the planes are all the different requests people are making to an AI model. And without a controller, you get a total gridlock.
I mean, think about it. You might ask an AI a really simple, quick question, but at the exact same time, someone else is asking it to write like 1,000 lines of code. If you don't manage that traffic, you get a huge bottleneck. The little plane gets stuck on the taxiway, waiting for the jumbo jet to lumber out of the way. For you, the person actually using the AI, this whole mess just feels like a really frustrating delay. It's that pause before you see the very first word pop up on your screen. That moment you're wondering, is this thing even working? Well, in tech terms, that wait is called inter-token latency. So how in the world do you solve this digital traffic jam? Well, this is where a really cool open source project called LLM-D comes in. It's designed to be that much-needed air traffic controller for the world of AI. LLM-D stands for Large Language Model Distributed. And that last word, distributed, is key. Its whole job is to manage all these AI requests way more intelligently, spreading them out across the system to make everything run faster and, this is a big one, a lot cheaper. Okay, so how does this intelligent routing actually work? What's going on under the hood? What's the secret sauce that makes it so much smarter than just taking requests as they come in? Well, the heart of LLM-D is something called an inference gateway. You can basically think of this as the head controller up in the tower. It doesn't just wave planes through. It stops and takes a hard look at every single request that comes in. And what's it looking for? Well, it's analyzing a few critical things. First, how busy is the whole system right now? Second, based on the request, how long is this thing probably going to take? And third, and this is super important, it checks to see if it's had a similar request before. If it can pull parts of the answer from its memory or cache, it can get you a response way faster without having to do all the work from scratch. But here's where it gets really, really clever. LLM-D understands that an AI task isn't just one big job. It's really a two-step process. First up is the prefill stage. That's where it digests your prompt and figures out everything it needs. Then comes the decode stage, which is where it actually starts generating the answer, word by word. And this is the absolute game changer. Instead of using the same type of hardware for both jobs, LLM-D splits them up. It sends that heavy lifting prefill task to GPUs that have a ton of memory, and then it lets the decode part run on different hardware that can scale up or down. It's like having a special, super long runway just for the jumbo jets and a bunch of smaller ones for the little planes. It's all about total efficiency. So, all this clever engineering has to pay off somewhere, right? Let's get to the results, because they are honestly pretty incredible. First off, let's talk about the slowest 10% of requests. The ones that are so slow you just want to give up and close the tab. LMMD improved the performance on those by 3 times. That means the absolute worst user experiences got a massive upgrade. And then there's this number. This is the showstopper. LLMD made that time to first token, that moment you see the AIs actually alive and working, a staggering 57 times faster. 57. The feeling of speed becomes practically instant. Now, these numbers are not just for bragging rights. They have a huge impact on real-world applications and, frankly, the bottom line for any company that's using AI at a serious scale. For a big organization, this means they can actually hit their performance goals and promise their users a certain quality of service. It makes AI reliable enough for mission-critical systems, the tools that absolutely have to work when you need them. And of course, by using all that expensive hardware so much more efficiently, it ends up saving a ton of money. So the shift here is what's really crucial. We're moving away from this old, simplistic round-robin method that just passes requests along and creates traffic jams. Instead, we're moving toward an intelligent, specialized system that delivers low latency and genuine efficiency. It's the difference between chaos and control. Look, the main takeaway here is pretty simple. As AI traffic just keeps growing like crazy, we can't just keep throwing more servers and more hardware at the problem. We have to get smarter. We need systems like LLM-D to be that air traffic control, managing the whole flow effectively. And that kind of leaves us with one final thought. LLM-D is a brilliant step forward for managing the complexity we have today. But as these models get even more powerful and woven into every part of our lives, it really makes you wonder, what other smart solutions are we going to need to invent just to keep up?